India. I'm in 2 a.m. in the night in Canada, but still I'm very much happy to just walk you through on a couple of cutting edge technologies, right? So today I'm going to just present you the cloud journey with how you started the cloud journey with Red Hat, right? I'll just introduce myself. I don't take much time. I'm one of the cloud solution consultant working for Mobia Technology Innovation. Just moved recently back to Canada in 2018. Prior to that, I worked for almost close to 11 years with Red Hat Consulting. So I worked for almost all the leading banks like State Bank of India, ICICI, IDBI, and all the exchanges like BSC or National Stock Exchanges, almost all the telcos, Vodafone, Airtel, Jio, on all the 4G platform as well as the cloud platforms, and GST and UAD for Aadhaar and everything, right? So if you see the amount of client I'm just talking about, you can understand the value of Red Hat and value of open source, how much it is penetrated into the market, right? So I'm going to walk you through the couple of things around Red Hat, what is open source, and what is Linux. So let's move on to the agenda. So today's agenda is more around making you to understand what is open source, right? So today we are talking much about open source, talking about Microsoft, we're talking about Linux, and the cloud, virtualization, containers. A lot of buzzwords going on in the market, right? I'm going to walk you through to make you understand what is open source, why open source, how the Linux is giving more comparative advantage over the closed source Microsoft operating systems, and a couple of slides on cloud to make you understand what are the different cloud models and different cloud services, and how virtualization play in the cloud and the containers. The new new buzzword is the containers. Okay. I'll if you see the open source, it's more of an philosophy, right? So it's something like when you're creating some when you're developing some solution, right? When you just have some ideas to implement, okay, you can just always just create always do it in an open source community, right? So what is open source is something like you can develop if you have some thoughts around okay, I want to develop some application, you can always go to the community, open source community, and just and submit your code. So what will happen is once you submit the code in an open source community, developers and volunteers across the world will try to log in, try to have a look on the code and try to further engage the code, right? So that instead of you working alone on a specific set of application, there are multiple tons of developers across the world work towards the same application and improve the efficiency, bug fixes, so that it will be more reliable and stable, right? So the open source is something like it's a free. You can access. You have a complete free to access. Okay? It's not closed, and you can access any place at any time, right? So what is free software and what is Linux? How the Linux is doing free software? How they are making money, right? That's the biggest question to everyone. So if you just see, the freedom means you can just create your own program. For example, in a university, if you want to create some application, you can just start developing the application based upon open source. You don't need to do everything from scratch. You can just use the existing program already in the community, and you can repurpose it, right? And you can make your own changes because all the source code is free for you. You can just make the modification and distribute and copy, and you can just distribute and modify it, and you can share it with any community, and you can redistribute it, right? So the freedom in the sense you have free access to the source codes, right? If you just see if you see the Windows operating system, everything is closed, right? You will know only the start button, but you don't know what is happening behind the start button, right? But in the open source world and the Linux operating system side, You have the complete control of, okay, how we want to look like, how the operating system you want to look like. If you take Windows 10, okay, currently in the market, you can't customize to a certain level, right? So you can only customize what Microsoft dictates you, but you can't go beyond certain level. So if you see the Linux and open source, you have the complete freedom. You can say, okay, I want to customize this operating system. I want to just use it for all the students in my university or my college. Right? You can completely have the freedom to do all the changes and redistribute it without any licensing or any subscription. Okay, that is what the freedom means here. And moving on to the next slide, if you see the open source and closed source, right? Open source is more of, as I talked about, you can modify the source code of an application, be it an application in the sense, be it's going to be an application like in WhatsApp or whatever the Facebook, everything is an application or or a software, like, right? Whatever you can call it, an application or software, and even even the operating system also fall into the same category, right? So how it works is something like there is always there is a community, open source community. Uh, uh, there is a open source community. So whenever you just develop a new code, whenever you're developing a new application, you always submit that code or application from the community, so that the community will just have a second look on your code by different developers across the world and contribute and enhance your application or software, right? It's a bigger community, right? So because of more and more people are working on the same application, if there's any issue or bug fixes, it will be fixed very fast. Because if you go back to the closed source companies like Microsoft, you have only the code will be available only to the employees who are developing the application. But since the open source model, the application is available to almost everyone across the world. So if you are interested on the specific set of application, you can just have a look on the source code and always try to develop, add features, do bug fixes, and whatever you like interested, right? And how the open source model works. Okay, if you see the diagram here, we see the diagram here. If you're a developer, you will just there are two things. One is the source code, another is compiled program, right? Source code is the raw program, what you're writing. Okay, at the end of the day, once you written the program, you should compile the program and give it to the end user, right? So the how the open source works is, like I said, you as a developer, you are just creating an application, and then you compile from the source code, you compile as a program and submit it to the community. So developer across the world working on the open source world just have a look onto it based upon their interest, right? Might be some developer have interest around web application, some developer have interest around chat application. It's completely depends, right? You can create a one community, right? So it will have more visibility to your code, what you built by the different developers, and then it will help you to engage the application. And as I said, you have the volunteer across the world working on the same code by pulling in from the open source and do all this engagement. Moving to the next slide. You'll ask me the question of, okay, how the licensing work, right? So all the open source falls under the GPL. It's called the General Public License. It's a centralized body who is managing the whole licensing, how the licensing works. So there is no restriction. You can just take whatever the code. For example, if Red Hat is offering some code, you're free to download it and make your own changes and redistribute. Okay, and redistribute and then use it for your purpose, like for your college, for your university, for your own application. You can any software on the GPL, you can always have the complete access. It's a free to access. And if you just come to the same story with Microsoft, they have the end user license. It's called EULA, the short form. You don't have those freedom, right? If you don't have the freedom, you can't assume. assume you are running on a Windows 10, you're opening a notepad, right? Or a Microsoft Word application. If if it hangs, you don't have a visibility why it is happening, right? It might be due to some more load on the system that you will know only from high level, right? So you might be running with some 4 gig memory on your laptop or a PC. You might open the hundreds of applications that might cause a load, but you don't have the visibility of how it is designed, how it is developed. You can't go and change the way it look like, right? Because you are restricted to the end user license agreement, which will allow you not to change anything from Microsoft standpoint. And if you see the Linux world, there are more than 300 distributions. It's a little bit of older slide. And if you can see the Ubuntu, Fedora, SUSE, these are the major operating systems, right? And Fedora is an open source version of the Red Hat operating system. So Debian. So you have the freedom to choose whichever you like, and start installing those operating system and get your hands on, right? There are close to 300 different distributions. You can choose whatever the best fits in, right? And we have a couple of slides in the later section which will cover how to get those operating system as well. Not only the operating system, we have free software as well, right? So you can see the Firefox, you can see the VLC media player, whatever available on Windows, it's also available for Linux. So not only as a server, even as a desktop, we have so many applications available for on Linux as well, right? You don't think, okay, the Linux is only for server operating system. It's not like that. I can see most of the people from IIT use Ubuntu or Fedora kind of Linux operating system for the entire entire graduation, right? So you have all the application available, whatever you have it in for Windows. You have the same application available in Linux as well. Let's move to the next slide. One of the classic example of extensive use of the Linux operating system is your Android phone. Nowadays, almost everyone is having the Android phone. You know how many number of applications in the Google Play. You have more than 750 million devices. So the complete Android operating system is running on the modified Linux operating system. It's not anything on Microsoft or anything. That shows the powerfulness of the open source and Linux operating systems. And why Linux, right? So Linux is free for download. There is no licensing or there is no cost attached to it. You can have the freedom to download it, and you can customize it, and you can share to the neighbor, or you can share to the friends. There is no need of any additional virus, antivirus software you need, and it's you have the full sort of software application available. Like I just said in the previous slide, you have the full suite of software application, and low resource on the hardware side. Something like it's not like Microsoft. You'll have a you open some hundreds of application, and it start hanging. You have to just forcefully reboot the laptop, right? So I never seen my laptop or my Linux machine got hanged in my last 15 years career in my career in the industry, right? From day one, I started using the Fedora Core 2. That is one of the Linux operating system. Be it my professional as well as my as well as my for personal use. So it's available in almost all the languages, like in all Indian languages across the world. It's available across all languages, and it's the Linux is running from almost everywhere, like in from the smartwatches to all the way to the supercomputers. Okay, this is this diagram will show you the complete system diagram of how the Linux operating system will look like. End of the day, you need some hardware, right? It's either going to be a server or going to be a PC or it's a laptop or it's a smartphone or an Android tablet, whatever it is, it's in hardware. On top of the hardware, you have the kernel. The kernel will be provided by the Linux operating system, be it the Red Hat Linux or it's an Ubuntu or it's going to be a SUSE or a Fedora. So it's a kernel is the main software which will do all the hardware level abstraction. For example, if you connect your keyboard onto a PC, right? So the software which is running on top of it, right? Like either if you're logged into the GUI and if you're typing username and password, you're giving an input to the laptop, right? So how it is interpreted and then translated. So the kernel will have all those device drivers which will detect your input, like either a mouse or a keyboard, and then execute on the kernel level, right? And the kernel level, right? So this is a typical diagram of the Linux system, full Linux system diagram. And if we move further down, we'll see the different component, right? And typical any operating system. Okay, there are 4 or 5 major core systems, right? We'll see that one of the systems which will manage all your hardware on all the buses, all the PCA devices, and everything. And networking, so sockets, it should manage all your networking and everything, and storage to store the data, and memory, which will just do all your load, all your application and memory, and process and CPU standpoint. So this is the complete heart of the next kernel is heart of the complete the system. So this slide talks about different subsystem, how the networking is handled by the kernel, how the storage is handled by the kernel, what are the different components, how are the different function implemented in the kernel is um, it's used by the storage, memory, and processing, and for other purpose. Now to the next slide. As I said, starting from servers, laptops, also desktops, supercomputers, mainframes. So you'll find Linux everywhere, right? So, and more importantly, the top 10 supercomputers in the world is powered by the Linux operating system. So that shows how powerful it is. So Windows is quite extensively used by the is for desktop based application. The reason because most of the application and in the earlier days was developed for Windows. So if you be it an Adobe or an Acrobat Adobe, we have Adobe for Linux as well, or any gaming application or any business application like SAP or database, Oracle database client level application. So more application most of the application vendors started developing those applications for Windows on a desktop level. And you can see Linux only in the predominantly on the server market, not much on the desktop market. But you can see the recent notice from Germany. In Germany, the whole government is completely shifting away from Microsoft to the open source operating system, okay, to cut the cost and to improve the performance. Slowly, the desktop adoption is growing because of cost and everything, but due to the application compatibility, so still most of the people are prefer to use Windows from a desktop level. But on the server level, and be it in a stock market or be it in a telcos, be it as in an enterprise banking, all your application, if you're logging to your banking, internet banking, okay, so all of the front end web application and the back end application servers and the database, everything is running on Linux because of the performance. Similarly, if if you're just dialing a phone from your laptop, from your Android phone, if you're dialing someone, if you're doing an SMS, so everything, all the system backbone system is powered by the Linux operating system because of performance. Just on the next slide. Okay, what situation where you can deploy Linux? You can deploy Linux anywhere, right? Be it in a lab, in a college, or in a university, or in a department, and or in section, or in a business as well. Like it is in a business will act. You can deploy a desktop, a server, and almost everywhere you can use it. It's Linux. There is no restriction. Okay. So why Red Hat? So why Red Hat? So what Red Hat is doing different, right? So we have close to 300 more distribution Linux operating system. What Red Hat is doing something different than other operating system. It's because this you can see the Red Hat is the first $1 billion Linux company, right? So because what they done is they created a community. They created open source community, and then they started contributing to communities. Right. We see the next slide. More of why Red Hat, because the Red Hat act as a catalyst. Let's assume you're creating an application, some chat application like in a WhatsApp, right? So you don't want to keep it closed. As your final year degree program, you're just creating some chat application. You don't want to keep it with you. So what you can do is you can just always submit your code to the open source community. So what Red Hat does is Red Hat will uh, picks the right project, whatever submitted by the different team, and uh, start contributing to those codes. Not only Red Hat, from there are SUSE operating system. Almost all the Linux developers will start contributing to those code based upon the interest, right? So what Red Hat does is it acts as a catalyst, okay, for the communities of customers. In a catalyst in a community in the sense it's a central body, so where a different group of people will submit the code, right? And contributors are yours, right? You are the developer, you are the contributor. You are just developing a chat application. You are contributing something to the open source community. Red Hat is acting as a catalyst. If the particular application, whatever you're developing, right? Let's say you're developing a database. Okay. So if the data, Red Hat will always have a look on. Okay, the database is okay. So it will just check. Okay, if the way it is designed is really powerful, then it will just pick up the specific set of project and start contributing to the project from the Red Hat engineers and developers, along with you as well as with other developers in the community, and it will so that it will create a better technology. So you creating an application, okay, with your two eyes and a brain, okay, and assume you have tons of different thousands of different developers contributing to the same code. It will make a huge difference. So everything is in open source. Okay, whatever you just started the development, and whatever the contribution that Red Hat made as well as other partners made to your code is completely open source. So it acts as a catalyst. So it will take the code. It will take the code. Let's say it's take the database application, whatever you deployed, and Red Hat will do all the security, performance testing, and it will do all the testing which is required for the application to be adopted by the enterprise, like in the biggest banks or telcos or exchanges. And then give support to those applications because they are production application. It needed support, right? So that is what Red Hat is doing, and in the meantime, it is giving back to the community as well. So if you see the slides, there are close to 100,000 projects. Like if you see the project, like in Fedora, it's an operating system, right? It's an open source operating system backed by Red Hat. It uses so the Fedora it's one of the project like what I said. You can just go to fedora.org and start do the contribution as well, right? So it will go back to the community. So you can start improving the Fedora. Similarly, you have the Red Hat virtualization. You have the different set of products. So what Red Hat does is it picks those specific projects and productize it by just doing the complete security hardening, security testing, performance testing, and do the complete testing before giving it to the end customer. So yeah, that is what Red Hat, that is why the Red Hat is acting as a catalyst to the customers by taking the code from the community and do all those extra checklist required by the enterprises for them to host application. This is a classic example. If you see the Fedora, we just on the previous slide, it's under the Red Hat as a company. It's a community driven, so people developer across the world will contribute to the operating system and improve the operating system. And very importantly, it release every 6 months, like a Windows 10 and Windows 11. Like similarly, we have version Fedora operating system. It releases every 6 months, so it is very fast, right? So if you as an enterprise like in biggest banks like an SBI or what are the exchanges like BSC or NSC or another biggest corporates can't keep on upgrading the application every 6 months. They have specific life cycle, might be in a year or two, based upon their uh, based upon the policy. So this is how the Red Hat is acting as a catalyst. It takes Fedora, okay, and create a new spin called Red Hat operating system, and it releases and do complete performance testing, security testing, and stability and stress and all the testing and everything, and release it to the release a commercial version of Red Hat to the enterprise. So there is no, it won't charge you for the operating system. It will only charge you for the support. Let's assume if you're a customer, if you want to buy a subscription for Red Hat for a year, you have to pay for the subscription, not for the actual operating system. Yeah, similarly, CentOS is another community driven. So it's almost following the same cycle. Yeah, Red Hat Enterprise Linux is based upon the Red Hat, one in the middle, the slide. So how it does? If you just see the slide, it's more about create, share, and collaborate. Right? What it does mean? You don't need to take a permission. You don't need to take permission to contribute to the code because no, it's completely free. You can contribute to any code, any application, okay, hosted on the open source community, and you're free to do it. Be it the Fedora operating system by Red Hat, or whatever the project driven by Red Hat or any other third-party vendors. Right? If it is in the open source community, you are free to access the source code and make and modify or enhance it, and you can redistribute with your own name. So there is no restriction. So what is the source code? We are talking about much about the source code. What's all the source code means, right? Let's assume you're using an WhatsApp application, or using some any application, or Facebook as an application, and a mobile phone, right? So everything is an application, right? So the application, how it is built. Right? Let's go to the basics. Let's say the simple example. It's one of the very simple example. It's a Hello World program, so everyone come across in your third year, second year, third year computer science. If you are computer science students or an electronic, mostly everyone from engineering this graduate levels. So if you see the Hello World program, it's created by a developer. Just as a basic example, it's a source code. Uh, the code, whatever the programming you're doing is just a source code. Okay. When it will become an application, if you let's assume the source code on the top is like a Facebook application written by the Facebook developers, right? You can't use the raw source code. Okay, so you need to compile it as a binary. Then only you can install it. Let's assume the source code, whatever the top is a Facebook application developed by Facebook engineers, and the next step what they do, they will compile it. as a binary and push it into your Google Play Store, right? Then from the Play Store, using your Android, you can just download and install it. This is how the whole application works for any application in the world. Okay, this is how it works, right? If you go to the next slide, this is what Red Hat is doing. Okay, Red Hat is developing this application. Let's say the Hello World is one of the application. Okay, it is sharing that application to the community. Similarly, you can replace that top one Red Hat uh, with even let's assume you are developing the code, or Red Hat is developing the code. The one in the top and the developer is anyone in the community, right? And you're submitting the code to the community. When you submit the code, you have multiple different users will just who are interested in your application will just keep on started developing the same code, enhance the application, add additional features, and commit the new binaries. Okay. And they can reuse it or giving back to the community. Let's say if you see the same example, and you can see the same Hello World application is written with by one user with the WhatsApp, another user with the Bonjour, right? So that they can modify it. You can modify it. You can always improve it. So you can improve your application. It is not necessary you have to follow the same thing. You can always improve and create your own binary and give it to the world. So what Rara does is just selling the binaries. Whatever the users were created by different so the different the if you just see it just uh, it will just take the code committed by different developers across the world, and it will just do the security test and performance testing and selling it to the customers, and charging only for the support. Yeah, this is what more about open source and Linux. Let's move on to the cloud, right? So if you just see the cloud, I hear about a lot of buzzword, the cloud, it's happening in the market, right? So what is the cloud? Something like cloud is some simple term. It's something like it's a network. It needs some, if you access something over the internet or over the network, okay, like be it an application like a Gmail, or be it another application like a Facebook, it's everything is over the cloud because everything is hosted not locally on your lab or something. It is hosted on a centralized data center. So anything you access over the network or internet, okay, other than your local LAN, right? You can call it as a cloud. That is what the simple terminology is all about. And the classic example is what cloud offers, right? Let's assume in your university you have a server, right, which will give you an access to the internet. Let's say it's called a proxy server. So you need to to set up the server, you need to procure a hardware, and then you need to procure the operating system. You need to procure the hard disk. You need to just plug in all your network cables. You can just plug in all your network switches to bring it up and everything, right? So instead of doing everything, so what the cloud offers is everything is deployed and keep ready for you, right? So it will offer you the storage, it will offer you the compute, it will offer you the application as well. But you can access it over the internet or network. So it's more of accessing over the internet or network is on a for a storage or compute resources. This is how the cloud computing architecture look like. If you see you have different people sitting across the world with accessing from the phone, accessing the PCs and laptops connected to the centralized data centers. Okay, and coming to the cloud concept, right? There are two. Cloud is based on two different concepts. One is the deployment model. Another one is a service model. Okay, so let's see what is the deployment model and service model. Let me check the time. Okay, I'm running at 2:30. Okay, so the deployment model. What is the deployment model? Deployment model defines the type of access to the cloud. Like you can see them. There are four major clouds. One is the public, the private, hybrid, and community. There's a new trend going on. It's called multi-cloud. Okay. So this is a major cloud. It's a major deployment model. What it means, right? It depends upon where your cloud is located. If you see the public cloud is located and managed by the top service providers like in AWS or Microsoft Azure or Google Cloud. They are a complete public cloud. Be it Alibaba Cloud, so they are a complete public cloud. What is private cloud? Private cloud is something like, an organization, you can create your own cloud and keep all your and manage all your infrastructure, right? So it will offer more security. If you see the banking and financial industries, they're very keen, very have very strict compliance on security, right? They can't move the data, they can't keep the data outside of the premises because of security complaints. So the private cloud will be useful for such scenarios. And a community cloud. So we have it's one of the area terminology not widely used, but it will be used by different group of organization or most of like a government organization. Let's say we have NEXI. NEXI is a National Informatics Center from it's one of the biggest uh, government body. They have different offices across different location across India. So they will have they will have the own cloud. Okay, so they will access by the group of organization because Nexi might be integrated with the military, defense, and a lot of different. So those kind of community cloud. And hybrid is something like a mix of public and private cloud. Let's assume, yeah, let's assume, yeah, you're working for a banking, you are working for a banking and financial sectors. Uh, ba- uh, so you can keep all your database, you can keep all your application and everything on your local uh, data center, which is running on your private cloud, and you can just host your web application on your on the public cloud. So what are the advantages? Well, one of the public cloud is, okay, you can easily scale, right? So because of the web server don't it's not going to store any data. It's just going to, whenever just hit some, okay, any back.com, it'll just go to the web server. The web server will just redirect the traffic back to the on-premise uh, uh, local private cloud, right? So this is a mix of public and private cloud. And if you just take the service model, right? So there are three different major service model. One is IaaS, it's called infrastructure as a services, and the platform as a service, and software as a service. What it is all about. So infrastructure as a service is more about getting the compute. It's like if you have a lab with the 50 computers, right? You don't need 50 compute. You don't need to procure 50 computers, right? So because everything will be all the compute with the CPU, memory, disk, and everything will be configured and ready for you, like the public cloud provider, like an AWS, Azure, uh, kind of providers. And you can start. You need only the device, be it an Android, be it a smartphone, or be a thin client, or your local your laptop. You can just log in always and then use those compute and storage. You will be built based upon the usage. For example, if you use one computers, right? It's called virtual machines. It's not compute. It's not physical. Even a couple of IaaS cloud offer the physical machine as well. Uh, Predominantly, most of the workload, whatever you're running, okay, on the cloud is virtual machines. So I'll just talk about what is virtual machine later in the slide. It's more related to the virtualization. It's like so it's more about IaaS cloud is something like you can rent a physical machine for 10 days or 20 days or a virtual machines. You don't need to buy it and keep it always with you. So for example, let's assume the best use case. Let's say we have the Big Bazaar or the DMart or the Best Buy. Okay, they have certain peak holiday season. They have the huge demand in um, buy and sell, right? So as a end organization, they can't. Okay, so if during the peak hours, they can serve the customers with the 10 computers, 10 servers. During the peak hours, they maintain 20 servers. Okay, but it's only for just for 10 days or 15 days. But because of the 10 days, 15 days, they have to keep keep the another 10 servers. They have to keep it powered on. They need to keep on maintain all those servers, right? You don't need to do it. So you can just, it's more about renting your compute, right? It's called IaaS. So classic example is just a bit of old slide. You can take Azure, AWS. Everyone falls into this category. Google Cloud. Everyone is offering the physical machine for rent and the virtual machine for rent. And the virtual machine includes your compute, CPU, and you can buy a storage as well. Okay, you don't need to buy any specific laptops or computers for those workloads. What is the platform as a service? Okay, platform as a service is a bit of you have a server, right? You have a server. You just develop an application, web application. So what you typically used to do is you will just buy a server, okay, and load an operating system, deploy and develop the application. To develop the application, you need some dependencies. You will install the dependencies and then develop the applications. This is very time consuming. So what most of the vendors comes up with the solution is you don't need to buy a physical machine. You can buy through IaaS model. You can buy you can rent a compute. So you don't and then to load an operating system, it comes along with the operating system as well. And the platform as a service offering will give you the complete package. Let's say I want to deploy a web server, right? So you have to say just click on deploy web server. That's it. You don't need to do all the dependencies. You don't need to install all the dependencies. So all the dependencies, runtimes, everything will be taken care by the platform as a service offering. And same Azure, Amazon, even Red Hat, everyone is offering the platform as a service. Salesforce.com is more of a SaaS model. I'll come to the SaaS in the next slide. What is software as a service? Okay, the classic example is your Gmail, Google Drive. Everything is a software as a service, right? You can say you don't own the compute, you don't own the application. Everything is run by Google or a Facebook. Okay. You're just logging in and consuming the application. It's called software as a service. Salesforce.com is like Google Talk or the Gmail Drive. So the classic example of the SaaS. You use cloud, yes. You can see the Netflix of the world or YouTube of the world. Everything is a cloud because you're accessing everything over the internet from your laptop or from a smartphone. So everything is a cloud. Whatever you just accessing. Just if you want to just have a look on feel onto it, you can just go to any of the cloud storage like Dropbox, and you create a username, and then you just connect to a laptop, and then connect to the Dropbox account, and just try to save some file. So it's a classic example of how the cloud is in use, right? Let me move to the virtualization. Have more slides to follow. Okay, what is virtualization? Okay, we talked much about IaaS, cloud, and SaaS, platform as a service, software as a service. So if you underneath everything, we need some physical server or virtual machine. Running physical machine is not a viable solution because you can't deploy close to 100,000 physical machine. So what industry comes along with is the virtual machine concept. So it's more about you have a laptop. Okay, if you're running a Windows 10 operating system, you can't run another Windows 7 or something. You need to reboot the machine, right? So this is so the virtualization solve the whole bottleneck. You don't need to reboot the machine. Instead, you can install software called hypervisor, and the hypervisor will give you to create another virtual machine. It's called you can on the virtual machine you can load your Windows 7 or any Linux operating system. So in parallel, you can run a Windows 10 as well as Windows 7 on top of it. That's about the virtual machine. It's more about segregating the single laptop or a physical server to multiple different machines, loading with multiple different operating systems. It's somewhat of history. It started with IBM in 1960s, and then it just come to 1980s because of the because IBM is very expensive. So then 80s, 90s, we have the again the virtualization development got stopped because the CPU don't support the virtualization. Then it again began in 1990. Then found the VMware started the whole thing, followed by Zen. Red Hat started with Zen, and then moved to the KVM. So if you see everything, right? So currently, all the cloud computing is using virtualization as a backend for the VMs, right? So all the let's assume if you want 10 if you want 50 lab machine, you can go to Amazon and just okay run 50 machines. So it means not all 50 machines are physical machine. It will be run on one big server. It might be on a 3 or 4 big servers. So you can just use the virtual machines. What are the classic use cases is the cloud computing, the classic use case for virtualization and virtual desktops. Let's say I just said you, so you don't need to save all your laptops and everything. You can just connect to the remote cloud, IaaS cloud, and you can save all your data, and then you can just switch off a laptop, and then if you just move to some other states, then you can again plug in into the internet and connect to the same machine, and you can keep on to the virtual desktop and mobile virtualization. It talks about the how the virtualization, how the pools are working. You can see the one of the compute load. It's completely virtualized. If you see the box in the top, you can see the Linux machine, you can see the Windows machine running a single box, accessed by different teams. Let's talk about the slide. Who are all the providers? So you can see the VMware started the whole game, followed by Zen and KVM. KVM is the default virtualization used by Red Hat. And if you go back to another university project in the Columbian University, created a complete mobile virtualization suite for the based upon the Ubuntu. It's another Linux operating system using the KVM as an hypervisors. Okay, so let's talk about the containers. Okay, so it's the current more the it's more about the containers. It's more of trend in today's IT. What is containers? So virtualization gives a lot of overhead. Let's say you have the physical hardware. Okay, you have the hypervisor software which will allow you to create multiple different operating systems, right, in parallel, right? But it is very challenging because you have to deploy the operating system on each virtual machine. Okay, there is 3 in our case, and you have to configure, right? And if even if you have to just keep on do all the maintenance, everything to overcome the virtualization challenges. Start the containers. So virtualization is more about dividing or it's more about just partitioning your physical hardware into multiple different unit so that you can create a virtual machine on isolated virtual machines, right, with the full blown operating system. Container is something more about you can use the one physical hardware and load the operating system. On top of it, you can use the same operating system and use the operating system level abstraction and create multiple different applications. Okay. This is how it's going to look like. If you see the diagram, uh, it's more of a packaging, right? Let's say I can say I want web servers, I want database, MySQL database or a micro MS SQL database. You can package all the libraries, dependencies as a simple container, and you can host it on the physical server. And you can usually move it from one server to another server. So there is no need of creating multiple different virtual machines and deploy and manage all the virtual machine and everything, right? It's the benefit is it's less resource overhead. You don't need to create different VMs, and no need of any specific operating systems support because the one operating system on the base machine is sufficient to host different containers, improve provisioning efficiencies, so much benefits. So if you see the Red Hat gives a complete stack. Okay, Red Hat will give the complete stack in all we talk about. If you see the OpenShift, I will give the platform as a service. It's a container engine, which will give the containers, and I will give the Red Hat virtualization. I will give the server virtualization technologies and IaaS technologies. that will give you complete, will offer you the complete stack from end to end for all the technologies what we discussed about, and how it will help your career, right? So Linux will help you to, if you're looking for a, there are two different role people typically will just get into. One is the more of administration standpoint. You can sort of support, technical support, moving to a sysadmin, associate consultant, or to all the way to the architect, cloud architect, domain specific architects, and from developer standpoint to sort of junior and all the way to DevOps and DevOps architect in the enterprise. This is how it will just move on. There's a couple of links. Okay, you can always use to start with. Okay, so this is the link you can start. The one on the top is a Fedora link. You can use the Fedora to download the operating system and install and try it. And a couple of self-learning you can do with Red Hat. You don't need to go to any training institute and do it, but you can just learn everything on your own. But this will give you the fundamental. But one thing you have to notice, I have a couple of other modules, right? Like for containers, for virtualization, based upon the industry best practices. If you see, most of the institutes will give you the predefined course that is not going to applicable to the industry you're going to enter, right? So we can customize specific use cases, how the telco is using virtualization, how the banks are using containers. We can always plan for some more session on it. I can just reach out to your organizer for it. I hope you can wish peace, love, and Linux. Yeah, that's an.